So back in 2008, this paper just appears online. It's from someone, or maybe a group, nobody knows, called Satoshi Nakamoto. And get this, it's only 9 pages long. But those 9 pages, they laid the groundwork for what's now a multi-trillion-dollar industry and totally changed how we think about money. So today, we're going to dig right into the original text that kicked off a whole financial revolution.
I mean, right out of the gate, the very first sentence just lays it all out. It's a truly revolutionary idea. It's basically saying, forget the banks, forget Visa, forget all of them. This was a vision for real, actual digital cash, the kind you could send as easily as an email, directly from me to you. No middleman, no permission needed.
Okay, so why was that idea so radical? I mean, what's the big deal? Well, to really get the solution that Satoshi proposed, you first have to understand the problem they were trying to solve. And that problem is our total, complete reliance on middlemen, these trusted third parties, for every single thing we do online financially.
All right, this slide really breaks it down. On one side, you've got the system we all know, the trust-based model. And the paper points out it's got these, quote, inherent weaknesses. Think about it. Transactions can be reversed, right? So we need these costly systems for handling disputes. That's why merchants have to ask for all our personal info. They're just trying to protect themselves. But then, the paper proposes this totally different idea, a model based on cryptographic proof. Here, transactions are pretty much irreversible. Sellers are protected from fraud, and you don't need that central authority watching over everything.
And boom, there it is. That's the mission statement, right from the paper. The whole goal is to swap out our need to trust a company or a bank with the cold, hard certainty of math. So the million-dollar question is, how on earth do you actually build something like that?
All right, so where do you even start? Well, the very first piece of the puzzle is to define what a digital coin actually is in this new system.
And the definition the paper gives is it's so elegant. A Bitcoin isn't a file. It's not like an MP3 you can just copy and paste. No, it's a history, a continuous verifiable chain of who owned it. A better way to think of it is like a title to a car, where every time it's sold, the new owner signs it, adding to the list of previous owners. It creates this public, unbreakable chain of ownership.
So what does it mean to send a Bitcoin? Well, you're not actually sending a file. What you're doing is using your private key, which is kind of like a super secret password that only you know, to create a digital signature. That signature is basically a public announcement that says, hey everyone, I'm transferring this coin to this public key, which is like a public address or account number. That signature then gets tacked on to the end of the coin's history. And the cool part is, anyone can look at that history and verify the entire chain of who owned it right back to the very beginning.
Okay, this all sounds pretty clever, right? A chain of signatures. What could go wrong? Well, there's a huge, glaring problem here, and it's the one problem that stumped people trying to create digital cash for decades, the double spending problem.
Right? Think about it. If a coin is just a string of data, what's to stop me from sending that same data to Bob and then turning right around and sending the exact same data to Alice? From their perspective, they both have a perfectly valid chain of signatures, but I've just spent the same digital money twice. How do you possibly solve that without a central bank looking over everyone's shoulder and checking the balances?
And here's the first big step in the paper solution: radical transparency. The idea is, instead of a private ledger locked away inside a bank, what if we had one single public ledger that everyone could see? If every single transaction has to be announced to the whole network, then everyone would know which one happened first. The whole network would be a witness.
Okay, but you see the next problem, right? A public ledger creates a new headache. If everyone is just shouting out transactions into this big network, how does everyone agree on a single official order of events? Who's in charge? This is where Satoshi introduces the most groundbreaking ideas in the whole paper. Seriously, this is the magic.
So the paper proposes what it calls a timestamp server. Here's how it works. The network bundles up a bunch of recent transactions into a list, or a block. Then it creates a unique digital fingerprint of that block. That's called a hash. But here's the crucial part. The fingerprint for the new block also includes the fingerprint of the previous block. This creates a chain, a block chain, and it's genius, because if you tried to go back and change even a tiny detail in an old transaction, it would change that block's fingerprint, which would mess up the next block's fingerprint, and the next, and so on. The whole chain would break and everyone would see it.
Okay, great. We have a secure chain. But that just leads to the next question. In a network with thousands of anonymous computers all over the world, who gets to decide which block gets added next? I mean, if anyone could just add a block whenever they wanted, you'd have total chaos, right? A million different versions of the history? We need a way for everyone to agree. And the answer is a concept called proof of work. This is the solution. The paper basically proposes a competition. In order to earn the right to add the next block to the chain, a computer has to solve a really hard math puzzle. It's kind of pointless, but it's difficult. It's like a global lottery that requires a ton of computing power to win. But, and this is key, once somebody finds that winning lottery ticket, it's super easy for everyone else to look at it and go, yep, that's the one.
And this is just pure genius. The paper puts it perfectly. Proof of work is basically one CPU, one vote. Your say in the network isn't based on who you are, but on how much computing power you're willing to contribute. The official history, the one everyone agrees on, is simply the longest chain. Why? Because the longest chain is the one that has the most computational work, the most proof of work baked into it. It's the most difficult one to fake.
All right, so let's recap. We've got digital signatures to prove ownership, we've got a public ledger so everyone can see, a chain of blocks to create a history, and this proof of work lottery to decide who gets to add the next block. So how does this whole thing actually run?
Well, what you get is this really elegant continuous cycle. New transactions get broadcast out to everybody. All the computers on the network, called nodes, gather them up into a new block. Then the race begins. They all start crunching numbers, trying to solve that proof of work puzzle. When one node finally finds the solution, it shouts it out to the whole network along with its block. Other nodes quickly check the work, and if it's all good, they accept it. And here's how they vote yes. They take that new block's hash and immediately start working on the next block, building on top of it. That's what locks it into the chain.
Okay, but why would anyone do this? Why would you spend a ton of money on computers and electricity just to run this puzzle? Well, the paper thought of that, and it builds in a brilliant incentive. The node that solves the puzzle and adds the new block gets a reward. They get to include a special transaction that creates brand new coins out of thin air and pays them to themselves. The paper compares it to gold miners spending resources to put more gold into circulation. This block reward, plus any transaction fees, is what encourages people to participate honestly and keep the network secure.
So just how secure is this whole setup? Well, this chart from the paper shows you. For an attacker to cheat, say to reverse a transaction, they'd have to secretly create their own blockchain and make it longer than the honest one. But as long as the honest nodes have more computational power, their chain will always grow faster. And look at the numbers. If an attacker is just one block behind, they have about a 20% chance of catching up. But if they fall 5 blocks behind, that chance drops to less than 0.1%. At 10 blocks, it's practically zero. After just a handful of blocks are added, rewriting history becomes basically impossible.
And that brings us to the conclusion of the paper. It just plainly states what it accomplished. It proposed a complete working system for electronic transactions that doesn't rely on trust. It finally solved that double spending problem, not by using a big company or a bank, but by cleverly combining a network of peers, some smart cryptography, and a really powerful set of incentives.
You see, the Bitcoin Whitepaper didn't just invent a new currency. It really proposed a whole new way of doing things. It's a new paradigm that leaves us with this huge, lingering question. What happens when our systems are built on math instead of middlemen? What becomes possible when we don't need to trust institutions anymore, but can instead rely on the verifiable certainty of code? That's the real legacy of these 9 simple pages.